Good day and welcome, and thank you for joining today's technical session at AGAT Laboratories Center of Excellence Michael DeSanti Center in Calgary, Alberta. My name is Bryan Chubb, President of AGAT Laboratories, and we're pleased to present as part of our commitment to science and technical education to our customers and to the industry, our session on excess soils in the province of Ontario. Today's session, we will go through the history of the excess soils issue in Ontario. We're going to talk about this new regulation that has come down, and it's been part of a long development process to come through to Ontario over the last 25 years. We're going to talk about the Ontario Typical Range Soil Study. We're going to talk about what you need to know. So we're going to break down all the new regulation in OREG 406 and give you specific actionable items so that you understand what you need to know about the testing requirements. We're going to spend a lot of time talking about the leachate analysis. And we've done a lot of research at AGAT Laboratories over the last 6 months to look at this regulation and to try and predict what is likely going to happen. This regulation is really trying to address the issues of excess soil in Ontario, and the question is, can we predict using historical data what's likely going to happen? And we'll give you some insights into continued research of what we're doing. Before I begin the technical session, I want to say a big thank you to the folks that really do all the hard work at AGAT Laboratories, which is the folks wearing the white lab coats and coming in and doing the analysis every day for our customers. And these folks I'd come to in December and said, hey, listen, here's this new regulation. There's a bunch of things that we need to look at. Who's in to do some research? And everyone quickly raised their hands, and this is a great group of folks, and I'd like to acknowledge Penny Nihila, Kelly, Amin, and Nick Bolton for their efforts in this research. Also like to acknowledge some of our external partners and folks that we've worked with as it relates to this research on excess soils in Ontario. Stantec, Ministry of Environment, and also EXP Consulting. Specifically, I'd like to say thanks to the ministry, Ralph Ruffalo and Bridget Burke, who've been great folks to work with at the ministry to make sure that there's a great public-private relationship as it relates to new excess soil or new development of regulations. It's really important that there's great collaboration and communication between the regulators and those who are actually going to do the work. And we have a long history of working with the regulators, and this is another great example of where both regulatory bodies and commercial laboratories can work together to get an ideal situation. So the excess soil situation in Ontario and the issues that have occurred over the last 25 years, how did this all begin? So I will tell you my story as it relates to excess soils. And for me, it all began in 1997, January of 1997, when this memo came out from a gentleman from the Ministry of Environment named Crump. And this gentleman really changed the way that policy was set as it relates to dealing with excess soil. And when we talk about excess soil, I'll give you an example. If, let's say, for example, I'm working on a site and I'm doing a development project and I have an extra 5,000 cubic meters of excess soil that I can't reuse on my property, and I need to find a home for it. I will test that soil. I will determine whether or not there's any contaminants of concern and whether it meets applicable guidelines, and I need to find a home for it. And in pre-1997, what would happen is I would test that soil, and if I'm on a Table 3 commercial industrial property, and that soil was found to be able to meet those standards, I could go and send it to another site that has that same setting. So I could go send it to a Table 3 commercial industrial site, and as long as it met those site conditions, it was considered like sites. And that's typically how things went until this memo came out in 1997 from Crump. And Crump had said, you can't do that. Because excess soil is considered not a resource, it is deemed a waste until it is considered, or until it is tested to be proven that it is not a waste under OREG 347. So that was the ministry's position that was circulated amongst the industry. This is a fax that I received in 1998. It's been photocopied a zillion times. You can barely read the old typewriter setting here. And it says that in order for me, if I've got that extra 5,000 cubic meters of soil, in order for me to be able to send that anywhere and be reused, it has to be considered inert. And at the time in 1997, inert fill was defined as those that meet Table F, now known as Table 1. So you'd have to test your soil. It has to meet Table F, or now Table 1, and then it can be considered exempt under 347 and not a waste. And so what this has led to is a tremendous amount of challenges. And I'm going to explain those here shortly. I can prove to you that it's actually not 1997. It actually goes back well beyond that. This is a document from 1992 that was provided to me that there was actually a draft proposal out there for the management of excess soil, rock, and like materials back in 1992. So this issue has been going on for a long, long time, because dealing with and having to meet background soil all the time is very difficult to find soil that actually meets background. And so this has been going on for a long time. It's never seen the light of day until December of 2019. So there's lots of challenges over the years, so it's not that we were just delaying it and the ministry just wasn't addressing this issue. There's lots of challenges associated with getting out this particular proposal and policy. But again, it's been going on for a long time. So what is our core problem? What is our core issue here? This is a newspaper article from the Toronto Star in 2014 that really, I think, describes the problem. And that is all of the soil, when you have to meet Table 1, according to the Crump policy, and we would find a lot of soil that just wouldn't meet it. And so instead of sending it to an expensive landfill, these sites would be finding farmers and places to take this material. And so the media started following trucks leaving contaminated sites and finding them being dumped onto farmland. And I have my own personal story. A friend of mine has a landscaping company, and he was importing a bunch of fill. And he called me a couple years ago and said, "Bryan, I've got a real big problem on my hands. I've got the Ministry of Environment here, and they're ordering me to test all of my property now because they're worried about contamination that's been brought on site." And I said to him, "Please tell me you were testing this material." And he hasn't been. So he has imported a tremendous amount of soil, likely to be impacted. And this is our core issue, which is we have soil going all over the province, and it's not being tracked, it's not being managed. It is not considered a resource. In reality, soil in the province of Ontario should be considered a resource and not a waste. We are backwards historically in our policies, which is it is considered a waste until you can prove it's not a waste. And even when you try and prove that it's not a waste, Table 1 is very, very difficult to achieve. And I'm going to describe where Table 1 came from and some of the challenge with it. The other issue is that we only have so many landfills. We only have so many spots in our landfill, and we are filling up our landfills at a tremendous environmental and financial cost, and we're running out of space. And we're landfilling soils that could definitely be beneficially reused in a lot of cases. Sure, impacted material needs to go to an industrial regulated landfill. However, some of this waste that really, or soil, sorry, that isn't heavily impacted could absolutely be beneficially reused, and that's the goal here. The other is around soil tracking. So I did mention there's trucks of material going all over the place. You just have to look on the highways in the province of Ontario and you'll see tons of dump trucks. And the question is, where did that soil come from and where is it going? And prior to this regulation, there has been no policy in place on how to track this stuff. The other issue that we have is it's difficult to find receiver sites. So if I've generated 5,000 cubic meters of excess soil, I need to find a home for it. And it's not like going and doing online dating where you can just go and type in and find your ideal match. Somehow we have to find these receiver sites. So there needs to be a way that soil can be exchanged, and we also have to consider things like geotech. Chemistry and the environmental aspects of soil is one component, but also if this soil is being beneficially reused, it has to meet geotech quality, and it also has to be geographically located near your site. It's not going to make sense to transport soil from Ottawa down to Windsor. It's just not going to be financially feasible. So there's lots of issues and there's lots of challenges that we've been dealing with, as I say, over the last 25 plus years. So I've mentioned Table 1, I've talked about it, I've talked about that's historically what you have to meet in order to exempt your soil from being a waste to being a resource. And the question is, where does Table 1 come from? Formerly known as Table F in the Guideline for Contaminated Sites, these values coming from a soil survey done in the late 1980s and published in 1993. And this was a soil survey conducted by the ministry. Excellent survey done at the time. The ministry went out to just under 100 different sites across the province, collected a bunch of soil samples, mainly for inorganic parameters. Limited organics, some organic testing. And I want to highlight, and a real important point here, is the laboratory technology used at the time was from the 1980s and in some cases even 70s. It's never been updated with the exception of a couple points in 2010. We still rely on these values today, and I'm going to demonstrate to you some of the challenges that we have with them. Here's what the background soil survey looks like in terms of the data. It's pretty simple, and due to my understanding that there was budgetary constraints and also time constraints, the ministry had went out to a number of sites, whether it be old urban residential, parkland sites, industrial sites, but they couldn't go to all the sites for all and collect every sample and test it for every parameter. It just wasn't feasible. So in this case, we have an example on the screen here for barium, and in this case, the ministry was only able to go to old urban parkland and rural parkland sites, and they collected approximately 160 soil samples, analyzed them. You get your 98th percentile, and there is your Ontario typical range, and that ends up being your Table 1 value. Now, there's been all sorts of challenges that I personally dealt with over the last 20 years with this particular document. The first one is BTEX. So benzene, toluene, ethylbenzene, xylenes, the values were set at background levels of 0.002 microgram per gram, and the technology in the laboratory has changed radically from 1991 to 2020, that's for sure. So prior to that in the 90s, we were using water extractions. Today, as everyone is aware, we do methanol vials, and that methanol is a much stronger solvent to extract, and so therefore we're getting backgrounds levels far exceeding the background levels in the Ontario Typical Range survey. This survey, because of the challenges that we were facing, the Canadian Petroleum Producers Institute, in collaboration with the ministry, went back to those sites for the soil survey in 2010, recollected samples, analyzed them for BTEX, and there was an update in the 2011 OREG 153 with much higher values for background Table 1 for BTEX and F1 to F4 hydrocarbons. We also have lots of issues with vanadium in the Thunder Bay area. It's just almost impossible to find soil that meets the Ontario typical range for vanadium due to natural deposits in that area, in Thunder Bay. As well, beryllium is a challenge in shales, and this has been addressed by the ministry, but point is that just because you have an exceedance doesn't mean it is coming from site activities and potentially contaminating activities. This also has an issue with groundwater. Just in the last week, we've dealt with issues where customers are seeing elevated cobalt. We're seeing in one case earlier this week, it was elevated uranium, slightly above the Ontario typical range. And this becomes a real challenge because you're chasing something that is naturally occurring, and it can cause a real hindrance to site development. The other one is free cyanide. Free cyanide is the standard is set at the Ontario typical range, which back in 1991 was developed at 0.051 micrograms per gram. Prior to 2011, the standard was actually 100 parts per million. And I'm going to tell you that's a lot of free cyanide. There was a correction made, there was an error in the model as we understand, and it then in 2011 changed to 0.051. And I call this free cyanide roulette. Right now we see approximately a 4% failure rate of free cyanide. And so we will see a lot of 0.06s, 0.07s because the laboratory detection limit is set right at the standard. And this is a challenge that we're working with the ministry right now to try and resolve. A bit of history, and we're still doing a look back in terms of development of regulations in Ontario. It really all started in 1989 where the first formal guidelines for contaminated sites assessments came out, which was the decommissioning guidelines. This is where the MOE inorganics package originally came from. And back in this day, in 1989, there were no hydrocarbon standards. The best that we could do in the laboratory was oil and grease. And so there were no hydrocarbon standards. So you can imagine you're doing a tank pull, and you're trying to assess a property, and the only thing that you're testing for is oil and grease when the contaminant of concern is gasoline. This all changed in 1991 when right out here in Alberta, the Management of Underground Storage Tanks project started, which is the MUST program. And that was a program designed to deal with all of these abandoned underground storage tanks. And it was an incentive to assess these tanks, pull them if they're not being used, and then clean up the tank nest. And if you're going to have that program, you need to have standards or guidelines of which to compare your site conditions to say, yes, this site is now clean. And that came out in 1991, and quickly that was adopted by the Ministry of Environment in Ontario. And it was the first analytical protocol that actually gave gas chromatography methods versus the gravimetric oil and grease. So that was adopted right away, and then formally in 1996 with guideline for use of contaminated sites. And then, of course, that guideline for use of contaminated sites turned into standards bound by regulation under Reg 153 in 2004, and later updated in 2011. So that's the background. This is where we've been. So our challenges are, we've got excess soil being generated in the province. It's going all over the place. It's ending up in the wrong places, and we're filling up our landfills with clean material a lot of the times. This has frustrated a lot of practitioners in the business. It's frustrated land developers, because also it seemed to be an unfair program, because there seemed to be a lot of road construction projects where millions of cubes of materials being moved, and certainly didn't seem to be that approach of having to meet Table 1 was being applied universally across the board. So December 4th, 2019, there was a workshop out in Eastern Ontario on excess soils. I attended this personally myself. I figured there would be about 75 people there. I showed up and there was over 400. And when the minister showed up, Minister Urick arrived, you knew something was happening, and this ended up being the launching pad for OREG 406, which promises, according to the minister, to deal with the excess soils regulation and put prime vacant lands back into use while maintaining strong environmental protection. Here's an important point. This is a phased-in regulation. It comes into effect in January of 2022. That's when the testing rules come into effect. So it's a staged approach. There's all sorts of different trigger dates. Another important date is 2025, where the landfills simply cannot accept material that is clean. So it's the opposite. So right now you're testing soil to make sure it's not contaminated going into a landfill. In 2025, you will be testing soil to make sure it's not clean. So the landfill may say, I'm sorry, I can't take your material because it can be beneficially reused. It's not a waste. I cannot accept it. So when did the testing rules come into place? And I want to be clear on something. Today I'm going to talk about, in this webinar, I'm going to talk about the testing aspect only. There's all sorts of different parts of this regulation. Our expertise at AGAT Laboratories is around the testing side of it. So this is what we're exclusively going to talk about. So when did the testing rules come into place? As of July 1st of 2020, if you want your excess soil to be exempted as a waste, you can start using the new testing rules and the new regulation right away. Now, as a result of COVID and the pandemic, the ministry has just issued an update that extends this by 6 months. So this has now been pushed to January of 2021. So prior to that, you can still use it. However, you're not going to be forced to, and ultimately, it is going to be up to the QP on how to test. So right now, you're not forced to follow the testing protocols in terms of the number of samples, the parameters, the protocols in which you're collecting the samples, but you're going to have to test, and you're going to have to defend why you've tested and the numbers, etc. So now it is considered, although the testing rules are not mandatory, it's going to be considered as best practice. As part of the package under OREG 406, there's a number of documents. I'm not going to go through these in great detail. There's a rules document. There's a rationale document that says how did the ministry come up with these specific leachate standards, and we'll talk about leachate standards, the new excess soil quality standard numbers, and it's a great document. And what we've tried to do is we've taken all of these documents and tried to pull out all the stuff that you need to know as it relates to the laboratory and the testing component and made it simplified for you on 2 slides, and we'll get to those shortly. The other thing that's real important to talk about is the BRAT tool. This is the Beneficial Reuse Assessment Tool. So the OREG 406 provides generic standards for soil and leachate in your generic settings. These can all be modified in a very simplistic approach with this Excel-based tool that allows you to remove pathways that aren't a problem on your site, and you can generate site-specific standards very easily through this tool. Now, I'm not a risk assessor, this is not our area of expertise, but I understand this is a very effective tool on a number of sites that we've been working with customers and QPs on. In terms of the organization of the new soil quality standards, they align very, very much with OREG 153. So Table 3 is, in OREG 153 is non-potable setting, and Table 3.1 in excess soil is the same setting. So it makes it very easy and very consistent between the documents. So anytime you say Table 3, it's OREG 153, and when you add the 0.1, this means we're talking about excess soils. So it's very simple and very much aligned, which was nice of the ministry to make it easy to follow and understand. Now, this is an important comment to make here, and this is your first, when did these rules apply? And the ministry has put forward a kind of a trigger point here that says, how much soil do you have? So if you're digging a swimming pool and you've got 5 truckloads of excess soil, this doesn't apply. So the number here is 350 cubes. If you're less than 350 cubic meters, all you have to do is your soil has to meet the applicable site condition standards, and you can take it to a like site. This is like it's 1997 all over again. Coarse-grained standards, by the way, not fine-grained. So if you've got a small quantity, you don't have to do a lot of the testing. You just have to confirm that what the site, site conditions they're at, and the standards as it relates to soil, and that can go to a like site, and so that's the big one. Now, majority of construction projects and projects that the QPs will be working on are certainly greater than 350 cubes, which triggers the new excess soil standards. And this new thing called the leachate standards. And this is where we're going to spend a lot of time talking about these leachate standards because it's new. Part of our responsibility is to also educate the QPs out there as it relates to testing protocols so everyone understands not only what to test for, but why these leachate standards have been developed. So the first question that I had when I first read the new regulation in December was, so our problem statement is we have to divert this excess soil that can be beneficially reused away from our landfills and yet protect the environment. And the question is this going to occur? So if you take a look at the standards, and this is a summary table that we put together that compares the 2011 and 1997 background values. So again, you had to meet background before to exempt your soil from being a waste. And then we compared that to Table 3 and then the new Table 3.1 to determine whether or not the new Table 3.1 standards give you any relief. Point is that is there relief against Table 1? And the answer is it depends. So let's look at a couple different compounds here. So if you look at toluene, for example, the background value in Table 1 is 0.2 microgram per gram. The new excess soil standard is 7.8. So that's a significant increase. So point is you get a significant amount of relief under the new excess soil standards, in which you could definitely be moving material that's toluene impacted that historically would have had to go to landfill or be treated as a waste, now can be moved to other sites and beneficially reused. However, where does toluene come from? The majority of toluene does come from gasoline, which is F1 hydrocarbons, and the background value is 25 parts per million, and the new excess soil value is also 25. So you get absolutely no relief. So the question is, I don't know. The question is, will you get relief? And the answer is, will these generic standards provide relief and solve our problem is yet to be seen. You look at metals such as lead, the background value is 120, and that 120 number comes from 1991, remember, that soil survey done in 1991. And it's 120 across the board. Same thing with free cyanide and other compounds. So the question is, again, will it make a difference? And we will have to see. So let's get into the new testing rules and what you need to know about the new sampling rules. And the amount of samples you need to collect and what you need to collect them and test them for depends on two different things. The first one was, where is the excess soil today? If the excess soil is sitting in a stockpile because you've already excavated, you've screened it, you've created these huge stockpiles on your property, you're going to have to collect soils according to the table on the top right of the screen. For any size stockpile, and again, greater than 350 cubes, where this will trigger, you have to collect a minimum of 3 samples. So that's the starting point. And then it just goes up from there until you hit the ginormous piles of 50,000 cubes, in which the calculation in terms of the number of samples comes straight out of Reg 153. Stockpile sampling, you need to collect more samples than if the soil that you want to excavate is still sitting in situ. And the reason for that is, if you are collecting samples and analyzing them in an in situ site, you kind of know where the contamination should be. You've got your areas of potential environmental concern, you've advanced test pits or boreholes, you're collecting those soils, you're analyzing them, and you should be able to target your testing. Whereas in a stockpile, you've excavated it all, it's all been mixed together, diluted, and you don't know potentially where those hot spots are. So therefore, the ministry is requiring more testing of that stockpile. In situ, the table on the top left there just tells you, based on the number of cubic meters of material, how many samples you need to collect. It's very simple in terms of the number of samples, but this will trigger your testing plan. So if you are looking at an excess soil situation, it's in situ. This summary slide provides you great guidance on how many samples do I need to collect, and then the second part is, what do I need to test for? So that what I need to test for question is answered depending on if you're in an area of environmental potential concern or not. So let's say, for example, you are in a background situation. It is a greenfield site. You're excavating a bunch of soil for a development project. You're putting in underground parking. There were no storage tanks. You know, there wasn't pesticides used on the property. There is no area of environmental concern. You still need to test for it. And you still need to test at a minimum for pH, hydrocarbons, and metals. You do not need to test for chromium, hexavalent chromium, that is, mercury or hot water soluble boron, but that's at a minimum. And this is all new. Historically, if you were undergoing a site excavation program and soil management program, if there were no areas of environmental concern, potential environmental concern, you typically wouldn't do any testing, because what's the risk? Whereas under this reg, you're going to be forced to test for those minimum parameters. However, you do not need to do the leach test, so that you are exempt from. Now, if you are excavating your soil and it is in an APEC, so there is an area of environmental concern there, you're going to have to test for the same thing: pH, hydrocarbons, and metals, and any other contaminants of potential concern. So if you also have concerns because, you know, there was a TCE used as a degreaser on an industrial property, you're going to have to test for those, just like you would have normally. So any other contaminants of potential concern, including salt, ECSAR, needs to be tested. And then here's the new one inside of an APEC. 10% of those samples need to be also analyzed for leachate. And we're going to talk about that in great depth. So how much do you need to test for, and what do you need to test for is all summarized on one sheet of paper here. It depends on if it's in situ or your soil is sitting in a stockpile, and then are you in an area of potential environmental concern or not. This is a summary of the number of samples based on the volume that was prepared by Stantec and shared with us, and it does actually compare the number of samples you'd have to collect in situ versus ex situ. So a great summary, and definitely shows that ex situ you're going to have to test more, and I've given you the rationale for that. So this new leachate test, what does it mean? Why are we doing it? Why is it required? This is all new to us. We've never done this before. So you're going to have to do a leachate test, but not for everything. Leachate is required and is part of the new regulation as it relates to the excess soil, all to protect the receiver site's groundwater and surface water. So if I've got an extra 5,000 cubic meters and I'm sending it off-site, that receiver site is unlikely to be testing their groundwater or surface water. And so the new soil standards have to be protective of the receiver site's groundwater. And there's two different pathways on which we're going to be protective. One is the SGW1 pathway in the conceptual site model, and that is the risk of soil to groundwater leaching of contaminants, and the other one is the other pathway is SGW3, which is soil to groundwater to then surface water and impacting a receptor. And in all cases, except for two scenarios, the excess soil standards, the bulk soil standards, are protective of those two pathways, except in two cases. One, metals. Two, selected organic compounds where the detection limit out of the laboratory couldn't achieve the upper threshold limit in the standard. And I'll explain that a little bit more. The point is, you don't have to test for leachate for a lot of our common contaminants. And I want to underline this and bold it and highlight it and put it in 100-point font. You do not need to conduct leachate testing for hydrocarbons, PAHs, PCBs. We have seen in the laboratory a ton of requests for these already, and the answer is you don't need to test for it. Once we give you the data, what are you going to compare it to? Because if you go to the standards, the leachate standards, you will see mostly dashes. So this is an excerpt straight out of the leachate screening values out of OREG 406, and you will see the majority of compounds here have no value. The only reason there's going to be a value is because it's a metal or the organic compound detection limit in the upper threshold limit was too high at the laboratory, so you need to do the leachate test. So what are we trying to do? This is our GW1 pathway and GW3 pathway. Again, we need to be protective that that soil, when it hits the receiver site, rainwater hits it, is not going to leach contaminants of concern and hit the groundwater and cause an adverse. So this is straight out of the Rationale document, where you can just see gaps in the literature where there's no soil leaching value for metals and also some of those selected organics. And this is straight out of the BRAT tool that demonstrates and shows that for those specific organics, the laboratory detection limit just isn't low enough. And so we have to actually test the leachate versus just using a component value. Now, what does leachate mean? What are we trying to do here? So what is the leachate? How do we define leachate? So leachate is defined in the regulation by either one of three different types of tests. You can do a 1311, the TCLP, which we're all very familiar with in terms of waste characterization for landfill disposal. So you can use the TCLP. Then this came out in December. You could also use the SPLP, which is 1312, which is the rainwater leach method. And we'll talk about that. Or number three is you can use any other method that the ministry's director approves. And that's an important mechanism, because once this is in law and in reg, it's very difficult to change. And so the third option there of a ministry's approved method that's not prescribed is a real important mechanism for us to use if we want to change the method. And we're going to talk about the work that we've done to change this method. So what is 1311? So 1311 is, again, the TCLP test. What are we trying to do with this test? We are trying to simulate what goes on in a landfill over the course of 20 years inside of 18 hours. So you've got waste on your site, waste soil, you want to send it to a landfill. The landfill requires under their permit for us to do a leach test. And so what we do is we take that soil, we tumble it for 18 hours with acetic acid. Why acetic acid? Because that's the most prevalent acid found into a landfill. We tumble it and then we analyze the leachate off of the soil. Makes sense for a landfill. I have no idea why we have a landfill method when we're trying to talk about excess soil. We're not in a landfill. So if I've got an extra 5,000 cubes and I've sent that off to a receiver site, why am I using acetic acid and why am I running a landfill test? So 1312 is the ideal test, and 1312 is the rainwater leach test, otherwise known as the synthetic precipitation leachate procedure. It's the cousin of 1311, and it's the same procedure except one difference, is which the pH of the solution. So here's how this works. Under the SPLP, we take 100 grams of soil to 2 liters of acid rain, and we tumble it for 18 hours, and then we filter the leachate and then test it for the contaminants of concern. It's a real simple test method, but very effective, that says, will that stockpile of soil that's been transferred to the receiver site leach contaminants of concern at a level that will ultimately create an adverse or an impact in groundwater or surface water? This is a summary table here that just goes through and compares TCLP to SPLP, and then most importantly, the recommendations that we're making to the ministry and that we are filing for director's approval for to modify 1312. And some have already been approved and in use. So again, the big difference is the leaching fluid. And so if we're trying to mimic acid rain, what is acid rain and what is the pH of rainwater in Ontario? And actually this turned out to be a very difficult question to answer. And the interesting thing is that this is a rainwater map from the United States, from USGS. It's quite old, but it still proves a point that says in eastern United States, where there's a lot of industrial activity, a lot of smokestacks and source emissions, the pH of rainwater is closer to 4.2. And the dividing line ends up being the Mississippi River. And west of the Mississippi River, the pH of rainwater is closer to 5 or even above. And so method 1312 actually states that the laboratory needs to know where your site is. And if you are west of the Mississippi, the laboratory is to leach your soil sample with an acid rain mixture of pH 5, and if you're east of it, 4.2. The question is, what's the pH of rainwater in Ontario? And good news story here is acid rain was a big hot topic in the 1980s. A lot of work done by the ministry and regulatory bodies to put in monitoring, to put in requirements, regulations, reduction strategies, and it's working. So the pH of rainwater has really risen over the last couple of decades to the point where the direction now from the ministry is that we are to leach with a pH of 5 because that's the closest to the rainwater in Ontario. So that's the method, and right now where it stands is the ministry has published a document and FAQs or guidance to all the laboratories that says the SPLP, even though the TCLP is considered acceptable in the reg itself, the guidance and the request from the ministry to the laboratories is the SPLP is the more correct method. So point is that you're going to have a real hard time justifying why you would run the TCLP. The method that we are using is the SPLP. So the ideal test method actually is not this 1312. It's a column test. And this is the Cadillac version of how to simulate what could leach off of your soil. It's a very complex method. It's a column of a glass column that contains 500 grams of your soil. And over the course of 8 weeks, the laboratory would pump through acid rain solution and collect the leachate. About a $3,000 test, 8-week turnaround time. I'm pretty sure that no one would want this method to be the mandated method. But the point is that how does this ideal test method compare to the simplified SPLP? And this is a paper produced in 1997, and where a comparison was done across multiple sites, multiple soil types, across various elements. And the point here is that the method compared very, very well. And if anything, the SPLP biased a little bit high relative to the reference method. And if you're going to be biased when you're talking about analyzing and assessing sites, you want to be biased high. And so point is that the SPLP is going to be a very good fit-for-purpose test for us in the excess soils. So the next promise I made to you is that, number one, I was going to tell you, what you need to test for in the bulk soil and when you need to test for it and under what scenarios. And next comes, when do you need to do this leach test? And so this is a schematic that we put together that answers those questions for you. And it just runs through a flow here that asks you questions about your site. And the first one is do you have more than 350 cubes of material? Because if you don't remember, that's small quantity, and this regulation doesn't apply. You don't need to do the leach test. You stop. The next question is, are you inside of an APEC or not? If you're not inside of an APEC, no leachate is required. Stop, just use your bulk data and move on. The next is, are there organics in your contaminants of potential concern list? If the answer is no, you just have to do the SPLP metals list where a standard exists. You are not required to test for any metals where there is not a standard. So if you look at the standards, the leach values, and there's a dash, you don't have to do the test. If there are standards for the organics of your contaminants of concern, then the question becomes, can the lab actually hit the detection limits? I mentioned that there's 2 reasons why you need to do the leach test. 1, it's a metal, and 2, it's a organic where the laboratory's detection limit was too high. Commercial laboratories can see much lower detection limits these days, and the point is that we may be able to help you actually not even do the leach test by looking at your bulk soil detection limits. So call us and talk to us about your project if you're staring down a huge budget for organic leach testing. The SPLP actually did make a brief appearance in OREG 153 in the era of 2004 to 2010 under the shallow soil definition, so it's not completely new, but certainly in the context of shallow soils, it is. So now let's get to the interesting stuff, which is around the predictability and some of the research that AGAT has done around to determine whether if soils could exceed the new leach standards. So we knew that TCLP was going to be an accepted practice back in December. Now it turns out that it's not anymore, or that's the directive that we've been provided. But we had thousands of TCLP results for leachate. And the question is that what kind of exceedances could we expect to see, or would we? And so we went into our database and pulled out almost 1,100 soil sample where we did a leach test. And we started plotting them and looking at the leach values in these bulk soils versus the leach under a TCLP. And here's the first aha moment, which was we started to see barium well in exceedance of the new leachate standard of 1,000 parts per billion in a ton of soil samples. In fact, the exceedance rate in the data set was 9.5%. That's a lot of barium exceedances, and I'm unaware of many barium impacted sites in the province. So this is a concern. This is a concern because what we don't want to have is we don't have values that exceed the limit, but yet meet the soil condition standards, and in particular, actually meet background table 1. So this was a first concern. We looked at cadmium in TCLP to determine the trends. The new standard is 0.5. The reporting limit from the laboratory under TCLP for 347 is 10, so unfortunately we couldn't actually tell anything here because the detection limit is too high. However, in chromium, the data set was great. The new standard is 50 parts per billion in the leach, and here's 1,100 samples plotted, and you can see the majority fall below the standard, several above. But when we look at the bulk soil chemistry for those samples that failed for the leach standard for chromium, those samples are highly impacted with chromium and should fail. And that's what should happen. In this predictive test, we should find soils that are exceeding and are impacted with these metals leach above the standards. But we shouldn't have the situation where the soil meets background levels and fails the standards. And that's what we found when we did this study. So we wanted to kind of see the leaching trends as it relates to metals. So I haven't explained something which is really important. Why do we have to do the leach test for metals? And the reason why we have to do the leach test for metals is we cannot predict how metals will leach out of soil consistently. We can't apply a formula to it. We can't apply a KOC or KD value and just pull it out, because it depends on the form the metal is in and the soil type. That will depend whether or not it leaches out readily or is very tightly bound to the soil and will not leach out at all. But we wanted to put this to the test. So we took a bunch of soil samples, 16 in fact, and they were contaminated and uncontaminated. So they had a broad range of concentrations of different metals, and we analyzed them using the SPLP procedure, and we made one important modification. 1312 requires a 0.7 micron filter. And we challenged this. The definition of mobile metals and what is going to be considered dissolved is, we all know in groundwater, is 0.45. So we also did a 0.45 micron filtration and the prescribed 0.7. Ideally, what we wanted to see was a very linear curve here where the mass of the contamination in terms of how much bulk soil was there in metals, and then the leach was linear. And this comes straight out of a document from New Jersey where they actually suggest that you do this and create this type of regression analysis. So you can predict, based on your bulk soil, how much is going to leach. So we did this. This is on the screen here is copper, bulk concentration versus leach, and unfortunately the correlation is horrible. And this just demonstrates the reason why we have to do site-specific leach testing. that for your site, we need to know if that copper is going to leach out. And it all depends, again, on the form of copper and your soil type. So in some situations here, we have not a lot of copper, and it really, really has a high concentration in the leach. So we've got a result here with 60 parts per million in the bulk, and it's leaching out well above the standard at just under 58. Yet some soil samples that are heavily impacted, 320 parts per million, are leaching out at less than 10 parts per billion in the leach. So a real mix here, and it, again, just proves out the point that says you got to do site-specific testing. So that's why the leachate testing rules apply to metals. This is a schematic just to talk about the type of metals. When we do analysis of metals in soil and groundwater, we just give you a number. We say the concentration of lead is X. When in reality, we're telling you a form of lead. We are telling you, for example, in soil, what is acid digestible. It's not actually all the lead in the soil, but we are using a specific prescribed acid that will mimic the stomach contents of a receptor. Someone who's going to ingest soil, what's the pH, how much bioavailable metals will come out. And so it all depends on the type of acid that you use. And that's exactly what we're talking about with excess soils in this leach. It says, what acid should we be using? So this is a picture of some of the soil samples as part of our study. And here's what we learned, and some very interesting findings. And when you're doing this type of research, you have a question that you're trying to answer with your research, and oftentimes you get the data back and it asks far more questions that you didn't even know existed. And that's exactly what happened here. So we did get some answers to some, and the first one is that leachable metals do not correlate to the bulk concentration. So sorry, we tried to get everyone out of having to do the leach test. You're going to have to do it because of that correlation is just very poor. Point number 3 I want to talk about here, and point number 4, is one that we just didn't expect to see. And that is 6 out of 16 soil samples, or 38% of them, failed the most stringent leach standard, but yet the bulk soil met background. So let's go all the way back to 1997. The Crump memo said that as long as you meet background, you can use that soil and it's considered inert fill and you can take it essentially anywhere. We're having these soils that meet background but fail the new leach standard, and that just doesn't make sense at all. We found 4 problematic elements. Vanadium, molybdenum, cobalt, and copper were the 4 elements that constantly failed. So that's the problem statement that we've been working on. The other one that we discovered, which again we didn't expect, and this is a summary table, we compared SPLP to TCLP. And we learned why that barium, if you remember I talked about barium, and 9.5% of the soil samples for a TCLP leach failed. We found there's significant difference between an SPLP and a TCLP. And my point is that the leach fluid matters. The TCLP is an acetic acid solution. And it turns out that acetic acid solution does a great job extracting out barium. And so you see in this particular sample, 448 parts per billion came out as barium. Yet when we did the SPLP on it, which is a mixture of sulfuric and nitric acid to mimic acid rain, was non-detect. Yet the opposite is true for copper, where under TCLP conditions, we get 7.6 parts per billion, and yet under an SPLP, we get an order of magnitude higher amounts of copper coming out consistently at 72. So the point here is that the laboratories need to be running a consistent method. Otherwise, they've given you the key code here on what test method to request based on what number you want. And that's obviously not what we want to do here. So this is further evidence that also supported the ministry saying, listen, we want everyone to run the same method, which is SPLP, which is designed to mimic rainwater, which is exactly what we're trying to test for when that receiving soil gets that soil and the risk. When it comes to these failures for copper and moly and other elements here, I went to other jurisdictions. We went to other jurisdictions that already have excess soils processes and standards out there and methods. And the one that I'm familiar with is New Jersey. So New Jersey's had a similar leach testing process, including a BRAT tool, all this kind of stuff, since 2008. So we thought, well, geez, let's see what they're doing and how they're dealing with these copper failures. And the issue is, or what we discovered is the standard down in New Jersey is 2 and 3 orders of magnitude higher than Ontario. So Ontario has very, very stringent standards for those 4 elements. So point is that if it was background coming from soils and that what you would expect under the SPLP, New Jersey's not worried about it because their standards are so high. The other thing that we discovered through doing some paperwork research in terms of the literature was we could modify this method, and does it make sense? And point is that we discovered a significant difference with the filtration of a 0.45. We also discovered a few other things. We discovered that it doesn't really matter what pH you start the leaching at, because it's an unbuffered solution. So if you start the leach test at a pH of 5, as soon as you add that soil, it's going to jump up to a pH of 8. TCLP is different. It's a buffered solution, so when you start the pH at 4, it's going to stay at 4 for the entire leaching procedure. So we found no difference between a DI water leach and a pH of 5. The other thing is we discovered through some literature reviews is we also discovered that a 1-hour leach is equivalent to a 18-hour leach. So we've been working on and have completed a validation package to validate and get approved a 1-hour leach test, which will certainly help, particularly when you are moving massive quantities of soils and you've got convoys of trucks waiting for soil chemistry data for the laboratory to produce same-day results. So this is going through the validation procedure right now. So we learned a lot through these phase 2 studies. We've been sharing it outward with the industry, including all the commercial laboratories, the regulators, and QPs. And that's part of our commitment to science, and part of the reason why we're doing this technical webinar today is to make sure that the work that we've been doing is shared amongst the industry so that we can all sort of learn through these experiences, because this is all new. And we got this regulation hit, and unfortunately we're learning after the fact instead of this work being done in advance of the reg. So what are we doing in terms of next steps? We're going to continue to work with the ministry, the laboratory technical advisory groups. We're going to finalize these leach protocols. We're very close. We'll be having a meeting in the next couple of weeks. Today is, we're at the end of June here, and so we're meeting in early July of 2020 to finalize these leach procedures. We're attempting to get consistency all amongst the laboratories, and here's the thing, we need a fit-for-purpose test. Just this week, we've had 2 clients call us with leach values for metals exceed the standard, yet they meet background, and that problem needs to be addressed. Whether it's a change in the laboratory procedure or a change in the leach standards, there's still work to be done out there. Just as a summary here, this is a case study and a great example of thankfully, some of the work that we've been doing has impacted the way that we're testing. So this is one of our first large projects that we've been working on excess soils with a customer. And in this particular case, this customer is importing 500,000 cubic meters of material from all sorts of different sites. So they are responsible, the QP is responsible for testing the incoming soil. And these are a bunch of soil samples that we did the leach for. So we finished the leach, and the resulting leachate, you can see there, very turbid samples, and we filtered them with a 0.7 micron. And when you filter them with a 0.7 micron, as per 1312, so following the method that we're supposed to under the reg, all of those soil samples failed. 6 elements failed for the leach standards, because you can see we're just not filtering out enough. And you can see the particulate at the bottom there. And so we were failing for things like silver. And I jokingly said to the customer, I don't think you have a contaminated site there. You've got a resource. Yet then we turned around and we took those same samples and we filtered them with what we had recommended, which was a 0.45. And all those soil samples significantly changed. You can see all the particulate is now gone. And in these particular samples, all of them then passed the new leachate standards. And they should have, because the table 1 values for these soil samples in the bulk all met background. And that's what this leach method needs to do. In the laboratory, we need to make sure that the testing that we do makes sense, and we're keeping contaminated site out of being reused and into a secure landfill. But also we're not sending unimpacted material to a landfill. It goes back to what we're trying to do from the beginning, which is we're trying to make sure we're achieving the goal. The problem statement is we're sending too much clean material to a landfill and we're not beneficially reusing soil. Soil needs to be considered as a resource, not a waste. So that's a lot of information. I promised you today that we were only going to talk about the laboratory testing, and that's what we've done. There's so many different aspects of this reg. Our area of expertise is in laboratory testing, and we had no shortage of material information to talk about. We've hit you with a lot of information, but today, if you walk away with a few things, this is what we'd like you to do, or walk away with. The first one is a consistent leachate method needs to be completed. We're close. And we've been doing a lot of work, and we're going to get there. But a lot of work's being done. Second one is that you only have to test the leachate where a standard exists. So you do not need to test for hydrocarbons, PAHs, PCBs, and it's mainly just metals. And I've explained to you why metals are required, because you have to do a site-specific, and we're all about, this leach test is all about protecting the receiver site from soil leaching to groundwater or surface water. Know your minimum samples you need to collect. Know what to test for. We've talked about in situ versus ex situ stockpile testing, the different samples you need to collect and why. We've given you two great handouts. One is around the flow chart of when you need to leach. The other is how many samples you need to collect based on the volume of material and if you're inside of an APEC and where the soil is today. Is it sitting in the ground or in a stockpile? The other thing I would say is reach out to us. Give us a call. When you're working on a scope of work, when you're working on a test plan, engage your scientists, and we'll help you walk you through what you need to test for and make sure that your testing scope not only meets OREG 406, but hopefully we can help you make sure that the budget that you're assigning to the laboratory is used wisely and you're not testing for things that you just simply don't need to test for. And the last point I want to make is just around data. We're living in an age now where data is being used and big data is driving interesting decisions and helping us provide insight. And I think we're a little bit behind in the environmental industry. The laboratories own millions and millions of data points, and it's being unused. And so my suggestion, and we'll be talking about this shortly with all the laboratories in the ministry in a few weeks, is to compile data. Is to grab data and put it all into a big database so that we're not relying on 100 samples collected back in 1991 for our soil standards, but we're using overall trends that says, well, what's the typical background or typical concentration scatter that we're seeing of free cyanide? And that should drive what our background is, not 100 samples collected using who knows what method in 1991. It's time for an update. I'm actually suggesting we don't go out to these sites. We use the power of all the databases, where the laboratories report to the ministry a flat file with no confidential information whatsoever about the site, but just simply data and results to get a population, thousands of data points to determine exactly what's going on with trends in the environment. So thank you very much for investing your time with us today. Pleased to present this information. We hope it was of value to you. Stay tuned for more. This is part of an ongoing series of technical education for our customers. Lots more webinars to look forward to, and thank you very much for your attendance.